Hello, I am Hamida Bey. I am Microsoft MVP in Developer Technologies and also MCT. I am Cloud Solution Architect and Docker Captain. Today we will talk about how we can harnessing the power of Azure API Management. We would like to build a robust and secure API. We will start talking about the API requirements, the different challenges where we are faces. After we'll talk about the different advantages of using an API management platform. In the next section, we will talk more about API management and the different features, how to build robust, secure, and scalable APIs is the third part. And in the end, we will share some best practices to secure your APIs. Let's start now. In today's digital landscape, APIs play a crucial role in connecting applications and enabling seamless interactions. APIs now play an essential role in modern web and mobile application architecture, data management, business integration, IoT interaction, enterprise application, and microservices architecture also. The use APIs follow the same path to innovation as websites. APIs have become an integral an APIs have become an integral part of software development, allowing different applications and services to seamlessly communicate with each other. However, as companies increasingly rely on APIs to streamline their workflows and enhance their products, they are also encountering several challenges in API integration. To engage in the API economy effectively, addressing several requirements and challenges related to monitoring, managing, and securing APIs is imperative. It includes the reuse because we need to integrate legacy APIs without the need for expensive rewriting, enabling a smooth transition and integration. Access without a headache because here we'd like automate the process of providing developers with easy and intermediate access to the API. This will reduce administrative complexities. Security is really important to secure our APIs, our platform that will manage our APIs, to ensure the robust security of backend system and implementing measures to protect APIs against unauthorized or excessive use, safeguarding sensitive data, for example. And we need visibility because we need to establish mechanisms to measure and monitor API usage. Why? Because we need to understand which APIs are in operation, the extent of their use, and identifying the parties involved. Successfully addressing these aspects is vital for creating a seamless and secure environment that encourages API adoption, fosters collaboration, and maximizes the benefits of participating in the API economy. But how we create this API, how we can support APIs. Companies releases APIs bear the responsibility of systematically advancing them. It's crucial to acknowledge that when developers use a published API to code programs, any substantial changes to the API require rewriting their programs, avoiding the imposition of modification to applications with every API change. IT organizations frequently opt for simplified facades. These facades effectively decouple the internal implementation from the API consumer experience because it offers streamlined API tailored for specific use, allows IT organization to modify the underlying implementation without affecting developers' application. So, what is the role of this facade? It enables transformation and enabling IT organization to support legacy applications. legacy APIs like XML, SOAP, for example, with never newer standard like JSON and REST seamlessly, without the need for recoding or reworking the original API. So the efficiency gained through reuse often justified investing in an API management platform. So what is an API management platform that will help us to create these facades? An API management platform is a robust software solution crafted to streamline the entire life cycle of an application programming interface API. So this platform offers a suite of tools, functionalities tailored to support various phases of API development, deployment, monitoring, and maintaining our APIs. It encompasses features such as API design, documentation, security, and access control, traffic management, analytics, and reporting, versioning, and lifecycle management. It includes also developer portals, monetize capability. By leveraging an API management platform, organization can efficiently create, publish, manage, and secure APIs, thereby enhancing interoperability, scalability, and developer experience while maximizing the value of their digital assets. So, in the heart of an API management, it acts like intermediary between the API and the users, whether they are customers, they can be partners, they are developer, instead of interacting directly with the underlying services. So developers connect to the API management layer, which furnishes all what we need as functionalities to save successful and to build scalable API use. What is the tool that we are able to use in Azure? So, what is the platform, API platform that we are able to use? So, Azure API Management is our platform that will include all these features. So, let's let's take a look about what is Azure API Management. So, this system is made by three, let's say, components. We start by the first one, that is API Gateway. That is the endpoint will accept API calls, it will route them to the backends. It verifies the API keys, different tokens, certificates, and any other credentials because we need to secure our APIs. We need a platform that will manage the security of our APIs. It enforces usage quotas and rate limits. It transforms your API on the fly without code modifications. We have catches backend response where setup because we need to improve the call. So we create catches here. And we need to monitor and add the logs. So in API Gateway, we logs call metadata for any analytic purpose. And API, Azure API Management is in hybrid mode because we are able to create a self-hosted API gateway internally. So you are able to manage your internal APIs. It's not only for external APIs. So with self-hosted management, customer can deploy the API gateways to the same environment where they host their APIs to optimize API traffic and ensure compliance with local regulation and guidelines. The self-hosted gateway enable customer with a big environment hybrid IT infrastructure to manage the API hosted on premises and across clouds from a single API management service in Azure. The self-hosted is a package, is as a Linux-based Docker container. It's really simple. You can create one container for your API gateway internally, and you can use also Kubernetes. It's one container, so it's really simple to set a self-hosted API gateway internally. Another component that is really important, that is Azure Portal. Azure Portal is the administrative interface where you are able to set up your API program. You can use it to define or import your API schema, package APIs into products, set up policies like quota or transformation on the API. You are able to get insights from analytics. You can also manage the different users internally. This is related to the admin IT. We have another portal, we call it the developer portal, that serves as the main web presence for developer, where they can read the API documentation. They are able to try out an API with interactive console. They create an account and subscribe to get API keys. Here we have the security part also, and we can access analytics on their own usage. So our API management platform, it includes, let's say, two planes. The first one is control plane. Why we call it control? Because we will control the use of our platform using two portals. The first one is the developer portals that we already described, or we can use it to discover onboarding of API within an API catalog on marketplace. We can access to documentation. So we have different features inside the developer portal. The second portal is the admin portal, is Azure platform portal, where we can add API to the API catalog, configure our API products, manage security, traffic monitoring policies. The second plane is a data plane because it can include the API gateways. It's the place where we will add our APIs, where we interact with our APIs. So, as we said before, we have two ways. We can deploy our API gateway in Azure remotely, so in the cloud, or we can deploy it internally using the self-hosted on-premises service implementation. The administrative portal and developer portal are integral to the control plane in this case. When an API gateway data plane is deployed, it registers itself with the control plane and retrieves relevant policies. So during runtime, the API gateway operates independently of the control plane for enforcing API request policies. However, it does receive policy updates and reports API usage metric and monitoring data to the control plane when feasible. Since communication with the control plane is asynchronous, the API gateway must be resilient to intermittent control plane availability or connectivity issues. So this specific architecture of modern Azure API management platform allow a single control plane to configure, manage your API gateways deployed across multiple cloud services provider. So we can have another part, we can deploy it in another cloud provider, this the API gateway. So how we create and build robust, secure, scalable APIs. So we have our platform that will allow us to secure, to do analytics, to interact with different customer user of my APIs, but we need to ensure that our APIs is really robust and secure and scalable. So delivering APIs is a critical task for an organization using modern application and integrating architectures. They provide a foundation on which to create a successful composable application architecture where partners, clients, and stakeholders interact through specific software. To ensure the APIs you deliver are valuable for the developer, integrator, and integrator using them, you must ensure that these APIs are sustainable. In other words, you must ensure they remain useful, secure, stable throughout their life and the life of the apps and processes that consume them. Providers of APIs deliver interfaces that provide access to functionality and data in a way that should be easy for API consumers to use. API consumers are developers who use an API's functionality to create new business solutions. API consumers rely on the APIs they use being secure, performant, stable, and available for the lifetime of their applications. poor API delivery has far-reaching consequences. Why? Because for both API providers and API customers, we need to have the higher delivery and maintenance costs. We have poor consumer experience and loss of revenue in this case. You can miss business opportunity through lower productivity and slower delivery. And you can increase the risk through poor security and identity management. This raises the question that ask how to deliver and how to support APIs and how developer can build robust and secure scalable APIs to be able to build valuable solution. This is the goal. So we consume APIs because we need to build specific solution, valuable solution inside an organization. So we have a platform that is really based on the consumer-centric approach to harmonize service implementation, architecture, and API lifecycle. So we need to ensure APIs are secure, available, and really well supported. We need to have always the documentation of the APIs, one for recommendation to when you create as a developer, we create an API. This approach contrasts with a bottom-up, provides a centric perspective by prioritizing the needs of API consumer rather than the viewpoint of the API provider. So we need to focus solely on the provider perspective, often leads to the creating of specific APIs that can serve as a simplest abstraction layer overlaid on an existing domain model without sufficient input from consumers, potentially compromising encapsulation and fostering coupling. So you can form a part of a set of services, model, consulting in direct access, and tie coupling to the domain model, leading to an desirable dependency, also known domain model dumping, for example, here. Uh, so you need to create an API that fulfill the requirement of consuming developer. Specifically, it should provide necessary and relevant functionality, offer clear definition in technical and non-technical contracts, be thoroughly documented and easily comprehensive, be well implemented to meet both business and consumer needs. We need also be able to test performance. It should be reliable, accuracy also. We need to ensure ease and consistency of implementation for consumers and be discoverable with transparent versioning, bug fixes, for example, because we know that it comes, but bugs it comes with APIs with any solution, but we need to have a clear vision about that with a specific version and support monitoring and analytics to uphold quality and availability, implement consistent security measures and access control. We will see how to do that in Azure API Management also. So let's see what are the best practices for security. The first part is implementation of authentication and security, which means that we need to implement access control for your platforms, administrative, followed by the security infrastructure that will protect both the platform and your APIs, because we need to secure the platform and the APIs. Not only is every API a potential attack surface, your Azure API management itself is a target for attackers also. So work closely with your security team to secure a platform as you link your platform to your authentication and authorization system. So you need to link it to that. Lock down all other access, ensure by that default administrative access account are removed, for example. You need to ensure you have multiple verification to do with your security team to ensure the security of your APIs, your security of the platform. You need to ensure that your DDoS protection will shield your platform, for example. If you use, for example, a CDN, ensure that you have correctly configured its cache policies to work with your APIs. So you have multiple things to do to secure your platform with authentication authorization, also with your APIs. So you need to check all these elements when you start adding your platform, API platform, Azure API Management in our case, and when you start creating and building your APIs. Another element that is configure endpoint protection capabilities. That's one of the most critical capabilities of API gateways is their ability to provide protection for API endpoints. So we have two types of endpoint protection capability, the rate limiting and throttling limit access to an API endpoint, while circuit breakers protect both of API endpoint and its consumer from any failure. Don't forget, if you are in hybrid environment, don't forget to implement an API mediation. Your API gateway is the starting point of your API mediation. You will use it to enforce security and access control policies and to monitor and manage traffic to your APIs. You will also do some amount of transformation of your in your API gateway, such as converting, for example, XML data packets to JSON. Use caution when implementing transformation in gateway, doing, for example, some both burden the gateway and create lock-in in your current vendor. So you have multiple things to do to implement an API mediation. If your Azure API management is deployed internally on premises in your site, and you publish APIs from on-premises system, you should prefer an ESB, DIP, or custom mediation located on premises. But if it's really deployed in cloud, it's hosted in the cloud in Azure. You can publish APIs, for example, from on-premises system. You can either choose an on-premises solution or use any infrastructure platform as a service as a mediator. If your Azure APIs management will just publish external API, in this case, you can use what is inside as a feature inside Azure platform, Azure API management. The last one is to configure analytic and reportings. We need to do that not only for Azure API management, but for with any other services inside Azure, because it's really important to have analytics. Analytics and reports are critical tools for understanding how your platform and the APIs it publishes are performing. So they also provide valuable evidence for key stakeholders that your platform and its APIs are meeting expectation and can identify cases where it's not. The data produced by your platform is useful to many audiences, and you should ensure that all of them are getting what they need. For example, if you are monetizing APIs on a per call basis, then you will need to provide access to information on usage and costs to the developer who are consuming your APIs. This will allow you to understand and manage their costs. To secure our APIs in Azure API management, we can use subscription. You can secure them by subscription or by certificate. Subscription keys or plans, how to access the policies inside the subscription, monitoring analytics. We can find them in subscription and certification. If we use certificates, how we can manage that, where we are able to store them in Azure Key Vault, not in Azure Key Vault, internally, externally, using another tool, or configure API management policies. Let's start by the first one, some best practices about securing your API using your subscription. When you publish APIs through API management, it's really easy and common to secure access to those API by using subscription keys. To get a subscription key for accessing APIs, a subscription is required because we need to link our API management to the subscription. And a subscription is essentially a named container for a pair of subscription keys. Subscription key is a unique auto-generated key that can be passed through in the headers of the client request or as a query string parameter. We see that here. So as you can see here, when you have your create your API management, you go to subscriptions and you can find the primary key. You have two keys, two type of keys, so primary key and secondary key. And you are able to generate them anytime. So if you have any problem of using these keys, you are able always to generate new keys and reshare again the keys with authorized APIs. And the keys can be passed by the request header or as a query string in the URL. As you can see here, you can get the primary key, secondary key, and you add it in the request header. And you can do that in website, by code, in another tool. For example, if you are using a specific platform that will consume your API, so you can pass the key in the header. For certificates, how we can use certificate? Certificates can be used to provide transport layer security mutual authentication between the client and the API gateway. So you can configure the API management gateway to allow only requests with certificate containing a specific thumbprint. The authorization at the gateway level is handled through inbound policies. It's really simple with certificate also. For example, here for APIs, you are able to configure your policies, how you can get. So this is operation, for example. I have an API demo that I'm using it, and you can accept client certificate in the conception tier. You have certificate authorization policies. You are able to configure it. You can check the thumbprint of a client certificate, and you check the thumbprint against certificates uploaded to your API management. We have multiple way to add policies, to add your certification, to add your authorization to your certificates. Thank you, and if you have any questions,